Today we will look into the sum of the first n term of geometric progressions. So I show you the number here 3, 6, 12, 24 and 48, and then we try to derive the formula from the progression given. If you know this one is a GP, what is the A here?
3,
Common ratio.
2.
Now I want to refer to the first four terms. So our S4 here is 3 plus 6 plus 12 plus 24. First term is A. Second term is A multiplied with the R. Third term is A multiplied with the R twice. Fourth term is A multiplied with the R 3 times. A is 3. AR is 3 times 2. Then 3 times 2 to the power of 2. 3 times 2 to the power of 3. And now, this whole equation, I multiply with the R. Okay, so if I multiply the R with S4, then I will get R S4. So if I multiply the R with the T1, what do you think I will get?
RT1.
RT1 also give you the second term. RT2 give you the third term. RT3 give you the fourth term. And lastly, RT4 give you the fifth term. So I get 2S4 equals to 3 times 2 plus 3 times 2 squared plus 3 times 2 cubed plus 3 times 2 to the power of 4. And I label this as my first equation and the second one as my second equations. Now we want to minus it. Do you notice that these two are the same? Same as these two and same as these two. Try to imagine. If you go and minus it, those will be eliminated. So S4 minus 2S4, I will get S4 minus 2S4 lah, right? 3 still remain 3. 3 times 2, 3 times 2 square, 3 times 2 cube, no more. So lastly is 0 minus 3 times 2 to the power of 4. It will give me minus 3 times 2 to the power of 4. With that, I get S4 minus 2S4 equals to 3 minus 3 times 2 to the power of 4. You can see the S4 here and here. So if I factorize the S4 out, what I get is S4 bracket, what left inside the bracket? 1
1 minus 2.
minus 2. Yes. Okay, this one also the same. We want to factorize the 3 out. What left inside?
1 minus 2 to the power of 4.
Yes. 1 minus 2 to the power of 4. So with that, we will get S4 bracket 1 minus 2 equals to 3 bracket 1 minus 2 to the power of 4. So next, we can make the S4 alone in front, right? So I want to move the 1 minus 2 to the other side, make it become divide. So I get S4 is equals to 3 bracket 1 minus 2 to the power of 4 divided by 1 minus 2. We try to understand the numbers here. The 4 and the 4 here are the same. It stands for the number of terms. So we label it as n. So the 2 here represent the common ratio. We label it as R. The 3 represent the first term and we label it as A. The 1 and the 1 here is the outcome after you factorize the S4 and the 3 out, right? That one is 1. No other meaning. So with that, we get a formula of the sum of the first n term, which is Sn is equals to A bracket 1 minus R to the power of n over 1 minus R. What happened if I multiply negative 1 and negative 1 to the numerator and the denominator? If I multiply the negative 1 to the denominator, I will get negative 1 plus R. So if I multiply the negative 1 to the numerator, the A will become negative. But if I want to remain the A is positive A, then the things inside will be negative 1 plus R to the power of n. So with that, I get my second formula of sum of the first n term for GP. A bracket R to the power of n minus 1 over R minus 1. So these two formulas, they are actually the same. I will encourage students to just stick to one formula. So we usually refer to the first one. Now let us try to apply the formula in our calculations. Maybe we try to find S8. A we substitute with 3 and then 1 minus R we substitute with 2 to the power of n is 8 over 1 minus 2. I get 765. Now, let us look at the second progression here. 3, 1, 1 over 3, 1 over 9, 1 over 27 and so on. You can see the number is decreasing. The first term is 3. What about the common ratio?
1 over 3.
1 over 3, yes. Firstly, we find sum of the first 5 terms. 3 times bracket 1 minus 1 over 3 to the power of 5 over 1 minus 1 over 3. Then you will get the value 4.481481,481. I want to emphasize how we're supposed to press the calculator here. Firstly, you press the 3, bracket 1 minus bracket 1 over 3 to the power of 5. Close the bracket. We divided by, here is important for you to open another bracket, 1 minus 1 over 3. Then close the bracket. Please make sure you put the bracket. We want to divide by 1 minus 1 over 3, right? Not divided by 1 only. If S10, 3, 1 minus 1 over 3, 10 over 1 over 3. So I emphasize one more time how we're supposed to press the calculator here. Press the 3, bracket 1 minus bracket 1 over 3, close the bracket to the power of 10. Close the bracket. Divided by, open the bracket, 1 minus 1 over 3. Close the bracket. Remember, you have to open the bracket here when you divide. And we get 4.4999233792 and so on. Okay, it shouldn't be a problem. So now I want all of you to try to press calculator S100. What value you get from here?
4.5.
Yes, you will get 4.5. When we increase the number of terms, the value is slightly increased a bit. What if S500? Tell me, what do you get?
4.5 as well.
Eh? 4.5 also. We try one more value. What about 1000?
4.5 also.
4.5 also. Yes. So now we try to understand what is happening here. Because this progression is keep decreasing, right? Imagine that when you count until 1000 terms, 10,000 terms, the value is very, very small, which is approaching 0 already. You total up them. Of course, you always get back the same value because the value at the back is too small. It will not affect the main value now. What happens if I wanted to find the sum to infinity? Multiply with 1 minus 1 over 3 to the power of infinity over 1 minus 1 over 3. From the example there, you can tell me already what can be the outcome.
4.5.
Yes, it will give you 4.5 as well. Okay, now we want to know the reason here. Okay, let us see. 3, 1 minus something. Calculator cannot press infinity, but calculator can press a very big value, right? Try you press calculator 1 over 3 bracket to the power of 999999999. Just press a very big value and tell me what are you getting there?
Is it zero, sir?
Yes, 0. Because the r is a small number. When you raise to the power of a big value, it will always give you 0, and that will cause the outcome always stop at 4.5. When the r is to the power of infinity, it will approaching 0 with the condition that the r is small. This 3 is our first term, a. 1 minus 0 is 1. 1 minus 1 over 3. This 1 over 3 is r. So with that, we derive the formula of sum to infinity, which is a over 1 minus r. To use this formula, you got certain condition where the r must be within 1 and negative 1. When the r is smaller than 1, when you raise to a very big number, it will give you 0. But this will not happen if the r is outside the range. For example, if r is 4 over 3, do you think 4 over 3 to the power of 1000 will give you 0? It will not give you 0, right? Same thing also if negative 4 over 3 to the power of 1000. So that's why the formula of sum to infinity only can be used in the condition r is within negative 1 to 1.